I want to give a brief overview over SDF, the semantic definition format. Some of you will know some of these slides because I gave a similar overview 6 months ago about what then was SDF, but these are slightly updated slides, so there are some new there is some new discussion in there. The image that Niklas showed should have made clear what we are trying to do here. So we have several ecosystem-specific SDOs, standard development organizations in IoT these days, and they usually do their own data models. They don't often actually call them data models, but that is changing. Anyway, they standardize the data that their IoT devices are sending, and they have their own way to document them as well. And given that applications may need to work with things that are standardized in several of these ecosystems, we are in a position where we actually need to translate model information between the ecosystems. Well, one-to-one translators are hard to do because really there are hundreds of these data models. So at some point in 2019, people decided to start liaison work between the different SDOs. The One Data Moc group is an informal liaison group, and this really is about a way to harmonize data models, to have a way to translate between them. And the obvious way to do this is defining a common format, and that is what SDF is trying to be. So SDF until summer has been defined by this informal liaison group, so that there are several organizations there, like OCF and OMA and so on, that have significantly contributed to that. And essentially what SDF does is it defines classes of things, and these things have interactions. These interactions are defined by affordances. This is a term stolen from interface design, where you have a device with a button and a knob and so on. These are affordances, and we use them for the different kinds of interaction that a device can have, like reading the temperature and setting a set point and things like that. So these affordances are not completely random. That we found that we have 3 major interaction patterns: property, action, and event. This will probably refine at some point in time, but right now that's a good way to start. And what SDF essentially does is naming these patterns and providing models about the data that these interaction patterns exchange. So when you read a temperature, you probably get something that looks like a number, and then you need to know what unit that number is in, and maybe other information as well, like when was the sensor last calibrated, and so on. So this is the kind of data we want to define in the simple definition form. So it's not a general data modeling tool, it's a tool for modeling the data that are interchanged as part of performing an interaction pattern. So the structure of SDF specification that One Data Moc came up with was putting these into JSON documents. That's kind of a logical decision when you think about the fact that this mainly goes into translators. So everything that's good for a translator to work from and to work into is useful, and JSON is kind of the standard generic data model that we use for things these days. And we also use RFC 6901 JSON pointers to point into these JSON documents, because we don't just need to talk about whole documents. We want to reuse data types exposed by specification and so on. In the long run, we want to have something like a basic core set of data types that specifications can reference. SDF 1.0 contains everything that's needed for that, but we haven't actually started exercising that. So I would say that the mechanism that is in SDF 1.0 is untested, and we really have to start making use of that to be able to say, okay, that's really it, we can live with that, and we probably will come up with a few tweaks for SDF 1.1. So SDF 1.1 is my name for the next version of SDF, but of course you might decide that we don't want to do it now, that we will do it in SDF 1.2 or whatever. So that's the purpose of the next segment, to talk about solutions and prioritizing. So let's talk about those interaction patterns. And I said there are properties, actions, and events. And these actually come in some variations, so that there are readable, read-only properties, there are writable properties. And if you are used to thinking of IoT devices in terms of REST, then this slide is useful for you. Otherwise, it's maybe not that useful. So a property has something like a get operation, where the client, which is not an OneDM term, not an SDF term, but it's a REST term, where the client can take the initiative and read some data. And a property can sometimes be put, for instance, if it's a set point or something that's not just a measurement. There are actions. So for instance, there might be an action to switch to a different scene in the lighting system. So actions are modeled as post interactions, and they have input data and they also have output data. And finally, there are events which don't directly exist in REST. There are various hacks to add events to REST, and there the initiative is on this thing side. Something has happened and the thing wants to let you know. And this is essentially providing some output data. So we see we have mostly data specifications, and we have a little bit of interaction specification as well. Yeah, how you exactly do this may be a little bit different in different applications. So in the REST application, an action might have something created that will provide event-like things while this action is going on, and so on. We haven't gone into that level of detail, so we haven't said how actions and events might relate, and so on. And actually, we have properties that are observable, which means that occasionally the thing actually will have the initiative and provide data to the client in the same way as if the client had done property get. So finally, we have events, and these are probably the least well-defined, but at least we have a way to say what the output data will be. So all these are talking about data. And talking about data, first of all, we need to talk about their shape. So is it a single number, or is it maybe an array of numbers, or is it a string? And these data definitions can be made in an affordance definition, or they can be made separately. In particular, if you want to use a common data type, you would do that. And for the data definitions, we currently use a subset of JSON schema org terms, augmented by SDF specific terms such as content format, nullable, scale, whatever. And what we haven't really done, we have talked about, and probably a few ecosystems have prototypes for that, mapping information that provides a way to bind these data definitions into the ecosystem specific formats and encoding. So it's not the point of the data definitions to tell you that there are 5 bits and the third bit from left does that. The data definition would stop at the fact that there are 5 Boolean values. So this is an example of the more general observation that really SDF is about information models. So we don't want to tie a harmonized data model down to one specific representation. So whether you use an integer that goes from 0 to 65,000 and 32,000 means 0, or you use a floating point value, this is really not important for the information model level, but it's important for the bindings. So that's something we will have to work on. And we also will have to work on making the semantics more well-defined. So we might want to do something like adding RDF-style links to our information models, so we actually know what the names mean. So if you have a data model that has 3 fields called R, G, and B, that doesn't mean that you understand what these 3 fields actually mean. And it would be good to actually tie them, for instance, to primary colors in some color space definition and so on. So we have a gap here between the description capabilities of JSON schema org, which is the data modeling language, and the information model that we are really trying to define. And this currently comes up in the enum concept. So JSON schema org has enum data type, which is essentially just a set of values, which can be, for instance, strings and integers. And each of these denotes some specific concept. So to the lower right on the slide, you see the enum that the OCF battery material model uses to describe the chemistry and the construction of the battery. And this is just a set of strings. These are the strings you can use. And if you have a potato battery on your IoT device, which you might have because it might be a toy, then you only have lemon potato there, even though you do not employ lemons. So yeah, it's somewhat difficult to define these enums, and they kind of get arbitrary after a while. There might be spelling errors. So the Pulvermacher's chain, the guy is actually called Pulvermacher, and there should be an apostrophe here to say it's Pulvermacher's chain. And also it's 150 years obsolete, so nobody uses these anymore at this point in time. So it's not even clear that they should be in there. So these enums are difficult, and it would probably be nice to be able to point to something that has done the work of enumerating the cases. So if we were talking about cheese firmness, for instance, cheese firmness actually has a definition somewhere, I forget where, and we would not get the idea of defining our own kind of cheese firmness enum, but we would like to point to that. But that may not take the form of an enum of strings. And on the other side, on the data model side, so maybe somebody uses the number 34 for lead acid gel batteries, and there's nothing wrong with that. That would be the job of the binding to say that what's lead acid gel in the model is actually 34 in the representation. So in SDF 1.0, we only have the possibilities that JSON schema org gives us here, and that leads to some pretty questionable definitions. So is an alarm always one of the 5 categories: general, fire, flood, weather, or security? And we also need to think about extensibility. How do we provide extensibility? Do we use something like IANA for registering code points? Do we use URIs so everybody can define an extension? Do we do both? And that's clearly something that SDF 1.1 needs to address, because we are getting more and more of these enums and need a good way to handle them in an evolvable way. So from these basic components, property, action, and event, and the data definitions that are referenced from these, we can build objects and things, and that's our composition mechanism at the moment, and that's probably also something that needs more testing at this point in time. We have a few SDF things, but mostly we have been defining SDF objects. So if you have an outlet with, if you have a extension strip with 4 outlets and 1 fuse and 1 metal oxide varistor in there, how do you build that composition? And how do you handle the repetition that is in that composition with the 4 outlets that are otherwise equal? So we haven't really done that a lot. And when we did SDF 1.0, we deliberately decided not to include the JSON schema object type, which really leaves a big hole in SDF 1.0, because we cannot really describe composition at the data model level at all. But the question we first have to answer is, do we really want to handle it at the data model level, or is there something in SDF that describes how this composition is done? So simply providing several properties also is a form of composition, but it's not always the right way to handle it. So some of the composition will be above the property level, some will be below the property level, and we have to figure that one out. We specify SDF specifications. And since the specifications are JSON documents, we also can specify them in a data definition language. And in this case, we actually want to use the full power of a data definition language. So the current draft has a CDDL-based specification, and that is also translated into 2 JSON schema org format definitions. One that is very open, so the framework one, so all extension points are open, but that also means that a typo that you make might be mistaken for an extension. And we have the validation schema that is limited to what is defined now. So CDDL has recently grown a feature called feature, and can handle that in one specification, and in the JSON schema org translation, we handle that with 2 different specifications. And of course, that's not all we need. So there's also some English prose in a Markdown document that is the internet draft. And there's also tooling that we use that might provide some additional specifics. So last slide, where are we? SDF 1.0 has been stable since June. We have a couple hundred data models in various repositories in the One Data Model organization, Playground, exploratory unit tests, and we have tools. We have been focusing a bit on getting the working group established in the last few months, but also on defining one data model processes that really aren't the domain of the ASDF working group. That is focusing on the SDF specification. But of course, OneDM itself needs to have ways of doing things, in particular doing the harmonization. Given that the ASDF working group is almost existing now, we can put the focus back on evolving SDF. And so we should define objectives for SDF 1.1, look at solutions, and start deciding. And all that shouldn't be done on a piece of paper. It should really be tested. And one way to test this will be next month, before IETF 109, the hackathon that comes with every recent IETF. And I have put in a hackathon project called ASDF Getting Ready for SDF 1.1. So that was my quick overview. And before we go into full discussion, are there maybe questions, clarifying questions that we want to discuss? Thanks. So from the point of view of SDF, Yang is maybe just another ecosystem that we want to translate into and from. And there has been some discussion already on doing this. Of course, we would need people from the Yang ecosystem to actually help us doing that.